Cool, slide drive. All right. My name is Haddix, and today I'm going to be presenting a talk that I gave at DEF CON called Hunt, Data-Driven Web Hacking and Manual Testing. So just by kind of show of hands, who here has ever used or assessed a website at least? Done some security testing on a website at all? Anybody? A couple people? So this whole talk is based around more effectively testing websites for security vulnerabilities. And so security engineering team and the security operations team at Bugcraft created a tool to do this. And we created it on top of a very popular tool that's already known called Perps. If you've ever used Perps before, it's an interception proxy that sits between you and the server you're trying to assess. And it tells you all the traffic that's going across. And so we built this tool on top of Perps. It's pretty cool. It helps you effectively root out bugs, and it helps manual testers who are doing this type of work. So I didn't write it alone. I wrote it with a colleague of mine, Ryan Black. I wrote it with a colleague of mine, JP Villanova, and kind of the whole team contributed, and then Bugcraft provided the data for the talk, which is really the powerful thing inside of this tool. So who is it for? It's for bug hunters, pen testers, people doing code analysis. If you write source code, you can use this talk to identify certain classes of vulnerabilities. And so we wrote it in Perp because we use Perp all the time to do hacking. So the problems that we started noticing when we were doing web application assessment, or just kind of over our careers, we've done this close to 10 years now, is that web applications now more than ever are increasingly complicated. They have many, many input points for data. They are very dynamic. And only if you've been testing websites for many years do you know off the top of your head where to look for certain classes of vulnerabilities. Now, we figured that with a data set as large as Bugcraft, and I don't know if any of you know who Bugcraft is, but Bugcraft runs bug bounties for enterprises all over the world. So we host their responsible disclosure and bug bounty platforms, and we let researchers off the internet register on our platform and hack their sites. And then they get paid to do it. If you find a bug and you're the first one to find it, you get paid a reward. That's what a bug bounty is. And so we had this giant trove of data about where vulnerabilities were actually occurring. And so we decided to make a tool around this to help people more effectively find these vulnerabilities. So the problem was that a lot of these applications were increasingly dynamic. There was a lot of more input points that we weren't seeing. Application assessors, people doing the testing, the training wasn't really getting out there of this like tribal knowledge of where to look for vulnerabilities, so we wanted to bootstrap that a little bit. And then the tool that a lot of people use, Perps, when doing web application testing, it had no, another problem was it had no way to track kind of a methodology for a test. So if some of you are web testers, you know that every consultancy, or even yourself, if you've written it for yourself or out of some book, most likely the Web Application Hacker's Handbook or something like that, has a methodology to follow to hack a site. Now, methodologies don't teach you everything, but they definitely keep you on course when you're attacking a website. And so we found that Perp didn't really lend itself to following a methodology. So we created a methodology section in this tool as well. So like the current solutions are a consultant or a badass hacker can eyeball a site, just look at it and say, yeah, it's probably vulnerable here. But if I'm a new person doing this, or even if I'm a seasoned person and a site is large, I can't do this effectively. This is not repeatable, not scalable. So they may or may not have a methodology, they may or may not have accrued this tribal knowledge, and they may or may not do consultant work, right? Some things that, one of the current solutions is also a dynamic scanner. So a lot of you might use like a WeaponsSpec or an Acunetics or some other scanning tool. And these are great as well, but they have limited test cases. You're only as good as the team writing the checks for that tool. And so a lot of times you miss out on the intelligence of testing these things manually. So what our tool does is it sits kind of in between these two solutions. It points you to the place where the bugs might be, but it doesn't test them for you. It doesn't assume that you can test them effectively. It assumes that you can pass it to a manual tester to do this work. And then also, dynamic scanners are pretty expensive, they're cost prohibitive, and they have limited detection resources and stuff like that. Okay, so that's when we brought our tool in. It's called Hunt. We bake in this tribal knowledge into this tool. We provide you methodology inside of Perps Suite. And we also, on top of this, not only tell you where the vulnerabilities are and allow you to classify your work inside of Perps Suite, but we also kind of loaded it with a whole bunch of links that we thought would be useful for testing for each vulnerability class. We kind of dumped a whole bunch of useful guides inside of some of the vulnerability descriptions that you can use to do the manual testing when we alert you. So this is level 1. This is the scanner part of the tool. There's 2 parts. There's the Hunt scanner and Hunt methodology, and we will show you these here. Actually, first we're going to talk about bug location. So the data set that Hunt alerts on was taken from BugCrowd's data. So BugCrowd runs over 600 plus. This is much higher now. This is DEF CON. This was at DEF CON that I pulled these stats, but 600 plus, give or take, bug bounties, public or private. A lot of our bug bounties are within private. On average, there are 2 targets per bounty. So let's say that we're talking about Tesla Motors or Tesla.com, right? Or one of our other clients that's public, right? They have, or DEF CON here for an example. DEF CON has defcon.org. They also have forums.defcon.org. They also have media.defcon.org. These are all distinct web applications. So we averaged out that out of our 600 bounties, let's say each one, and this is very fuzzy math, has 2 targets, just on average. Then we took a quick poll, how many average parameters, unique parameters, this is how you pass data into web applications, how many unique parameters do each one of these targets have? It came out to somewhere around BugCrowd had seen vulnerabilities on, give or take 18,000 parameters. So this is where the data set for the tool that we made came from, this parsing out of this data set. So what we did is we take these 18,000 parameters, we reduced them to only the ones that had vulns on them, vulnerabilities. Then we reduced them again to only alert you when we've seen parameters that have critical bugs on them. So SQL injection, any type of remote code execution through a web application, local file reads, things like this that are very critical in a web application when you get hacked using these things. Then we sorted by recurring instances, and we include these alerts in the tool. And so we did some manual magic here. Also, we looked at other projects that were looking at parameters as a way to pass input into sites. And we also added ones that seemed to appear in frameworks and in pen test data. So we really took a lot of data and stuffed it inside the alerts for this tool. So just a quick aside, just if you're not familiar with web applications and how they normally pass data, here you can see a sample of bugcrowd.com/programs. And programs here is the resource. And if I want to query programs and get some data or pass some data in, either via get or post, I need to either provide a parameter, and this is the standard format. So ID here in orange is the parameter, and the value of the parameter is A. So these are what we're looking for. These are what we're alerting on. So we are looking for risky parameters, basically, to help manual testers do their job better. This is the idea that you kind of get a lot, is that when you see, as a seasoned pen tester, you see whatever.php $ID equals. ID is a very vulnerable parameter usually because it interacts with the database most of the time. And so when you're doing web application testing, you pay attention to the ID parameter and you throw single quotes into it to trigger SQL injection. So that's what he's doing right here. He's sprinkling single quotes into ID. This is a meme. I don't know if this is a meme everywhere, but so this is the idea. You see ID, and you know, as a seasoned pen tester, that you need to test for SQL injection here, right? But actually, I'm new. I don't know. Actually, I'm not new, but I know. But a lot of people don't know, right? And there's a lot of other parameters like this that I need to know about if I'm going to be a good web tester. So that's what Hunt helps you do. So this is the idea around Hunt. And it's hard to see because of the screen resolution, but I can use the zoom function, which is fancy. Is that better to see? All right, here we go. Okay, so this is the idea of Hunt. It gives you alerts. So in Burp Suite, this is Burp Suite. We didn't make Burp Suite. We just made the plugin. Burp Suite allows you to create extensions for it. Now, if I look at the top of the tabs, these two tabs right here, Hunt Scanner and Hunt Methodology, these are our tools. I've added them into Burp Suite. What they do is, while we're browsing certain sites, they start telling us. They say, we have looked for, I think, 5 classes of vulnerabilities: insecure direct object references, server-side request forgery, SQL injection, obviously, debugging logic parameters, server-side template injection, OS command injection, and file inclusion and traversal. These are all P1 and P2 bugs, very critical web bugs that we see often at WebCraft. And so you can see inside of these menus that we get these little alerts in this tab. We say, there's 2 things in insecure direct object references. There's 5 things in server-side request forgery. And so these are common parameters where these bugs exist. And so here I've highlighted the URI bug. And if I click in the main window here, I get a little bit of information. And Hunt says, hey, at off.tesla.com, they are using this parameter that sometimes is vulnerable to server-side request forgery. Here are 7 resources for you as a manual tester to go check this manually to make sure that it's not vulnerable to such a bug. And then you have tabs to see the actual request and the actual response. So pretty simple idea, right? It's a level-up tool for your web testers. Okay. So let's talk about a little bit about the data set and why it's a super powerful data set for doing web application testing. In fact, if I was a scanning vendor in the room, I would be taking pictures of these slides because we're basically giving you all of this intelligence data on web applications. So SQL injection, right? The idea behind an application using a database and not using parameterized queries or prepared statements, not validating input, leads to this vulnerability where you can put a single quote in, or sometimes not even a single quote, and change the SQL query, right? And so this is a pretty general idea of SQL injection. Script question mark ID equals 1, right? So after ID, we've already talked about this, I would insert a tick, or I would try to do some SQL injection. These are the most common parameters you will ever see for SQL injection if you're a tester. ID, update, sort, process, from, fetch, column, code, string. These are the most ones that we've seen out of anything to do this manual testing. There's also some things in the bottom right corner, which are places that are not exactly parameters, but that we saw were most likely vulnerable to SQL injection across our data set, which turned out to be custom headers. And any payload that is using JSON or XML. XML services and web services that are in JSON are predominantly less protected for SQL injection than anything else. So Hunt will alert you when it sees any of these parameters. Make sense? Yeah? Cool. So the next bug type we focused on was file includes and directory traversal. So this is the idea that the web application somehow includes resources locally through the file system that a user wants to load. And so these are the common parameters that you will see in this attack. And so you can see at the bottom, usually you'll see like a load parameter equals something, and you'll see / and a file that they want to render to you as a user when you're normally using a web application. Now, if they don't code correctly and they don't add correct access control, you can put something like /Etsy password here and load the Etsy password page directly into the web page and steal all their passwords. This is a very common web vulnerability. These are the most common parameters when you're looking for file includes or directory traversals. A new bug that we saw a lot over 2016 and 2017 was this bug called server-side request forgery. Server-side request forgery is the idea that someplace in the web application, the developer wants to redirect you somewhere via passing a web link and a parameter. Maybe not redirect you somewhere, but also redirect you to another maybe part of the site. And so what they take is they have like a URI parameter, and the value of the URI parameter is HTTP something site.com. Or they omit the protocol altogether. They don't say HTTP : / they just say / whatever page, right? If this script that we're calling allows you to do certain things, you can actually be pretty malicious with this. It's very similar to local file includes. If they haven't coded this script correctly, you can read files off of the local computer's operating system, like the NC password file. If they've coded it kind of correctly, but not fully protected, you can port scan their internal network. The way you do that is you pass internal IP addresses and internal ports as part of this HTTP string here. You would say, if I wanted to port scan the server itself, right? Not from the internet, but from the internal network. I want to see all ports that are running behind the firewall. I could say go to localhost 127.0.0.1, port 80. And if this resolves or sends me or doesn't send me an error message through this method, I know that that port exists. And so server-side request forgery has a lot of different impacts, and they can be triggered in a lot of different ways, but it's one we saw a lot. And the worst case scenario is that they haven't done anything and you can read local files. These are the parameters, along with the ones in the file included directory traversal table that are most likely vulnerable to server-side request forgery. This is actually one where we see a lot of P1 super critical bugs on web so OS command injection. This is the idea of where you have a script that somehow interacts with the file system and on Linux or on Windows executes a command based on something you pass it in the parameter value. So here's an example of an actual attack. So here you can see cmd equals ls. It's called a Linux command, and an attacker has appended a semicolon and said cat etc password. Now this script, knowing that it's supposed to do ls, passes the ls command to the server, but then also takes the rest of this string and says, I will also do for you cat etc password. It gives you that value back. OS command injection is not seen a lot today. It's kind of a little bit of a thing of the past, but you still see it. So these are the common parameters when you see this type of web bug.
Jason, can we cut you for a second?
Yeah, what's up?
Like usual.
Genius media team, it's not a game. There's no contestant, you're only contestant. Human resources,
Thanks, man.
Thanks. Alright. Alright. Okay, so OS command injection. So pretty straightforward. So we only did 7 classes of vulnerabilities to start. We plan on extending the tool to do more. Insecure direct object reference. This is one that we see a lot too, hence why I put the little fire emojis here. But these are the parameters that you would see, that we see normally, where we find a lot of insecure direct object references. The idea behind this bug is that you have a script that pulls data back for a user, and if you have written your access control and authentication perfectly, I shouldn't be able to change that number and get someone else's data. But if you haven't, and I change that number to 21855, I pull someone else's data. These are the most often vulnerable parameters to something like insecure direct object reference. Now, the way that you trigger insecure direct object reference differs from some of these parameters. So right now I have a user parameter here, or user script here, and it's a numerical value. And that represents they probably had 21,000 users registered on their site. Now, if I'm seeing the email parameter, I am not going to pass it a number. If I see the email parameter, I'm going to try to put in someone else's email address and try to put in their pull out their account data. So that's how insecure direct object reference works. And these are the most likely culprits for that vulnerability. The last one is a kind of new bug that's come out in the last couple of years. A lot of web applications are starting to use templating engines to represent their web applications and routes. Things like Flask are very popular. You can write a web page in Python using Flask. Very awesome. I use Flask a lot to develop certain like CTF challenges and stuff. The idea is that there's logic inside of these templating engines. And if you don't correctly write your application, you can actually execute commands. And so the idea down here for this bug is that you go to a script, and instead of putting in a name value you put in a map function inside of curly braces. And so here I put 2 times 3. And then the output doesn't return my name, but it instead returns 2 times 3 is what? Somebody tell me? 6, yes. If it returns 6, then I know that there's a problem here. I can execute code. These are the most likely culprits in the table for server-side template injection, the most likely parameters. We also added in, at the very last minute, this idea of logic and debug parameters. So these are things that are not injections or per se vulnerabilities, but they're keywords. When we see them as a parameter, we really want to pay attention to them, and whatever they contain, whatever value they contain, we probably want to mess with it. And these are things like access, admin, debug, edit, grant, alter, clone. These are all keywords that tell us that it's dealing with some sensitive application logic, and we probably want to mess with this as a pen tester or a bug hunter. We want to look at these things. Alright, so the implementation. So we did this in Burp. We used Burp's passive scanning API. It was a pretty simple implementation. I didn't write this code, JP did. He wrote a lot of the heavy code. I did the data analysis. And then we created our own tab inside Burp Suite. So now I'm going to show you kind of what it looks like, and hopefully the demo gods don't fall over me. So, alright. So here, we're going to go to Tesla.com, which is one of Buckcraft's customers. They have an open bounty saying people can hack them. I'm not doing anything illegal. Discovery is not a crime. Port scanning is not a crime. Oh, that's the root concept. We don't want to test that. Or do we? The internet is a little shaky. Cool. Alright, so I'm going to Tesla.com. Now on the left-hand side is my browser, which is going to Tesla.com very slowly. And on the right-hand side is Burp Suite. Now I have Tesla already loaded up in here. And the first thing I need to do is basically set my scope for this test. And so Burp has this idea of, hey, I'm looking at all your traffic while you're doing an application assessment, but I know that you don't want to see everything. You just want to see stuff related to Tesla. So here, I have set my scope. I will zoom in for you, I promise. There you go. Can you see that? Yeah. So here I've set I want to see anything that has Tesla in the URL bar. That's what I want to focus on as a pen tester for this project. And then before I also had root config listed. But here's Tesla. You can see the Tesla site is loaded, Tesla.com. And so the first thing I have to do is set up my scope in Burp Suite. Now, my sites, anything that has Tesla in the URL shows up in my sitemap. This is every URL I've ever visited that has Tesla.com in the URL. So you can see 3.tesla.com, off.tesla.com, comparisons.tesla.com, forums.tesla.com. These are all sites that they own and manage. And they're all things that I'm interested in testing if I'm being paid to test their applications. So what I do now is I click on something like just the main domain, tesla.com, which is down here, https tesla.com. And in order to start Hunt, if I've installed it, and I'll show the install a little bit later, but I just want to show you what the tool does, I choose passive scan this host. So what this does is, since our tool is built on top of Burp and the passive scanning API, Burp will not spider Tesla.com. It'll go to every page that it can see X links deep, maybe 10 links deep. And then it will also execute every form, every parameter, and it will log it. And because it's doing this passive scan, now when I go into Hunt Scanner, the tab that we have added, now I start to get output. And so here I can see a couple of parameters that I already might be interested in for these classes of vulnerabilities. So insecure direct object reference. And actually I ran this across all Tesla sites, not just Tesla.com. So there is an ID parameter. Which vulnerability would we look for in the ID parameter? Can anyone tell me? Someone? SQL injection, yes. SQL injection. So here, this is a Tesla Motors site maybe. Actually, that's a marketing third-party site that they use, so we'll try to use something else. Server-side request forgery. All right. So server-side request forgery said at this IP address or at this domain from collector.teslamotors.com/beacon, we saw the page parameter. The page parameter was located inside of your application traffic. The page parameter is most often susceptible to server-side request forgery and sometimes URL redirects. Hunt recommends further manual analysis on the parameter in question. For server-side request forgery, Hunt recommends the following resources to aid in manual testing. And here are some tips and tricks for people just getting into manual testing. So here's the request that we can see, and the page parameter is in here. And also I can right-click in here and say send to repeater, and this is just a function of Perp. But if I go to repeater now, this is the request. And if I switch to parameter view, I can see that there was a page parameter somewhere in here. I think that was somewhere in here too. URL, yeah, page, here it is. So this one I want to test for is secure direct object reference, server-side request forgery, etc. So I would manually now test this using my newfound knowledge. If you go back to my scanner, there's other parameters it has marked here. The view parameter in this request. Let's see, where is this one? View. There is a couple in logic and debug. So load, something we definitely want to check out. Let me click it here. Go to the request. Here's a parameter with load. This one actually didn't pick up, but I found it because of Hunt. The U parameter actually contains a URL. So this one I would definitely want to check for server-side request forgery, URL redirects. So this is a general idea of Hunt Scanner. It will lead you to places where you need to focus your effort on as a manual web hacker. All right. Uh-oh. Cool. Okay, so that was the first tool, was this idea of this scanner that finds parameters that are most often vulnerable to things that we've seen in our data set. So if you're a scanning vendor, you should alert on those parameters. If you're a tester, you should stop and pay special attention to those parameters. The other part of the problem was that we saw that inside of Perps Suite, which we spend a lot of time in using this tool, there was no methodology section. The idea that I follow a testing methodology to make sure that my testing is repeatable, and there's no way for me to really add things to it, or basically take effective notes on things that I see. I have to use a third-party tool, like some note-taking, like OneNote or something like some note-taking app. That's not super effective when I have to context switch between Perp and something else. So these are the normal methodologies you would follow when you're doing web hacking. So the OWASP testing guide, the Web Application Hacker's Handbook, maybe a HIPAA or PCI type methodology to test web applications. These all have steps of things you need to do in order to say that you tested a web application. So we created Hunt methodology, which is the second part of the tool, which looks like this. So anywhere in Perps Suite, you can right-click on a request or a path and choose Send to Hunt Methodology. And we have two methodologies that we include with the tool. One is the Web Application Hacker's Handbook methodology, and the other one is a custom methodology based on the application, based on common web application functions. And here you can send requests to certain places. So the idea here is maybe you have a boss and you're a tester, or a client, and they want to know that you tested thoroughly all of these places of the application thoroughly. So what you can do with Hunt methodology is you can start sending requests to Hunt methodology and say, yes, I attested the account function, I attested the account registration function, I attested the file download and upload function, I tested all the transaction functions, and you can prove this by passing them the actual requests and export it and hand it to them as a JSON file. You could also script this up and turn it into a report. It's pretty powerful that way. So here, inside of Hunt methodology, you can go into these sections, and in the body of it, you can you can basically take all these notes that are stored for you permanently inside of this project. So you can write a description of the kind of testing you did. You can see all the URLs in this section of the methodology. You can pull up resources that you use to test these things, and you can put notes for other testers you're going to share your methodology with. So the big thing in here is that here is a section of the methodology. You're supposed to test for authentication bypass when you're doing web testing. I have 3 requests that I've loaded into methodology that say, yes, I indeed actually tested something here. I have notes related to this, and I can pass it to someone else. The big part of the tool is actually, it allows you to export all of this as JSON data. So you can click export when you're in the tool, which I'll show you later, and pass this not only to your client or your boss, but another tester. Let's say I'm really good at SQL injection, but I'm not really good at server-side template injection. I'm just not well-versed in templating engines. And I know somebody that is. I can export my full methodology minus the server-side template injection section, pass it to another tester. They can go do it, pass it back to me. Now we have completed a full methodology. We have each other's links and notes, and we can basically complete the test. So inside each section, you can also keep resource notes, and we provided some of these. So here for SQL injection are the top 5 links that people use to kind of cheat sheets for SQL injection. Pentest Monkeys cheat sheets, the WebSec sites, Evil SQL, Pentest Monkeys, other cheat sheets. These are all pretty standard cheat sheets when you're doing SQL injection. So you can keep these notes inside of the Hunt methodology tool. Then you can add just generic freeform notes in the notes tab here. So I tried to break this SQLite manually, then I tried to use SQL map. I can't do it, let's send it to Bob, who's better at SQL injection than I am. Okay, so here's the load and unload function. So I can save all of my work from this tool to a JSON file and pass it around. I can also load a JSON file from someone else and load all of their work into my Perps suite. This is the implementation we use for Perp. In order to create a new tab window was actually the most difficult part of this, is just to create a new tab inside of Perp. This is probably not as useful to a lot of people, but we included the code here in case you want to extend Hunt to do other things. This is the boilerplate code. This is all open source on GitHub. If you go at the end, you can go to bugcrab.com or bugcrab's GitHub, and Hunt is open source on that page. So now I'm going to show a demo methodology. All right, so here I have gone to Tesla.com. And when you go into Tesla.com to log in, make this big. Can you guys see that? When you go to Tesla.com to sign in up here, it actually doesn't use Tesla.com. It takes you to a subdomain of Tesla. It's called auth.tesla.com. So as part of the methodology, I need to make sure that I test the login functionality for this site. So I clicked on it. It's going to take me there eventually because the internet is slow. But it gets loaded into Perps suite. Now, here I can see, somewhere here you can see auth.tesla.com. Here it is. These are all the requests that have gone to auth.tesla.com. I can take this URL, right click, and send a Hunt methodology. Now I can send it. I can send it to any part of the methodology that I'm currently using. So this would be test the authentication mechanism. Now there's inside of, what you're looking at is the Web Application Hackers Handbook methodology that a lot of people use to do web testing. Inside of testing the authentication mechanism, there are several places I can put this request. Specifically, I want to test the account recovery, maybe password quality, username uniqueness. I can test any of these, but let's choose password guessing. All right, so I click there, and now if I go to Hunt Methodology, and I go on the left-hand side, this is the whole methodology. I drill down into authentication mechanism, and I say check for password guessing. If I go to bugs here you can see that this is where my request went. So for this request, I can say basically tested for default credentials. I have the URL here. Resources, I can say I use the OAuth guide and default password list. And then general freeform notes checked on or something like that. Alright, so now this is saved on inside of Perp. Now I can pass this to someone else and say I did this part of my methodology. So that's the basic idea around recording methodology inside of Perp Suite. Sorry, I'm turning my phone to try to get internet connection. Cool, so that's my methodology. So how do you install the plugin and use it inside of Perp Suite is the first step to try using the tool. So here, you can go to the Extender tab inside of Perp when you use Perp Suite. And what you're going to do is you have to make sure that we wrote our plugin in Python, and so Perp is written in Java. And so there is a bridge language called Jycon that translates these things. And so Jycon will basically get to load the Jycon interpreter into Perp. So that's the first thing I have to do here. So I choose select folder, and I choose select folder under Python environment, and I have to give it a file. To download this file off the internet, it's the Jython standalone jar file, and I select the file once I download it and load it into Perp. So that's the first part of installation. Then I go to load an extension. So I go to the extensions tab, or I go to the I go to the Extender tab and the sub tab that says extensions, and I say I want to add an extension. I choose that this is a Python extension, and I load the source code for Perp Scanner. This will be in the Perp store very soon. So Perp has like a Perp store where you can install plugins, and all you do is choose your plugin that you want. It downloads Jython for you. It downloads our plugin and installs it. So it should be much easier. But if you have to install it manually, this is how you do it. So you select Hunt Scanner here and import it. Then you have to set your scope, because by default, when you use Perp, it's passively scanning everything. So this actually happened when I was setting up the demo. I was browsing via Google, I was browsing via some other sites, and Hunt started to work on those sites, and I didn't want it to work on those sites. So it'll only test things that are in scope. So I've set my scope here to tesla.com under target and scope, and anything that contains the keyword tesla.com URL. And so now Hunt will only look for things on Tesla domains. Then you can set these two things. You don't want to do any live scanning, live active scanning, and you want to use the scope for the passive scanning, because we utilize the passive scanning API. This is actually, I think, the default, so you don't really have to worry about this all the time. And then you select all your URLs in your target sitemap. Select them all here, and you just say passively scan selected items. And this will start alerting you on parameters that you need to go test. All right, so Hunt is very extensible. So if you don't trust that BugCrowd's data tells you where these parameters are, you can do some other stuff here. So extending Hunt is as easy as modifying a JSON file. So for the scanner, there's a JSON file in the directory when you download the tool, and a list of the parameters that we alert on is in that JSON file. And all you have to do is create a new line, and here you can see I've added a parameter called sexy param. And this parameter will now alert whenever you're doing passive scanning. So it'll tell you, hey, we saw sexy param. This is most often vulnerable to OS command injection. So this allows you to even faster than a scanning company. Let's say you count on some scanning company to be your dynamic scanner. This allows you to extend the tool faster than even they can. Like the struts vulnerability took place in the very recent one took place in a parameter, I think. Well, actually, it was a method. It was an options method or something like that. I can't remember. But you could extend Hunt to find that as soon as you get that data. For large scanning companies, it takes them a week to get a new rule pack out for you to scan for this vulnerability and where it is, because they have their team that needs to build a new check, and then they need to roll it out to all their customers and do QA. With this tool, you can just add where the parameter was that the bug is present and scan your whole environment for that parameter to see maybe if that CVE is vulnerable on your server. So for the methodology, you can also add your own methodologies. It's also a JSON file, very extendable. So you just create a new methodology section, basically, in this JSON file. You give it a description, and now you can send requests and responses and upload it and export it as you need to. This is a demo for doing that. But I only have 3 minutes, so I might skip this demo. All right. So what are we going to do with this tool in the future? This is, if you're doing web application testing, this is a really powerful tool for your teams and for your individual testers. If you're doing bug hunting, this is also a very powerful tool. I do bug hunting. I would say from this tool, since I invented it, I probably made like $20,000 or $30,000 just because it alerted me to look at certain bugs, and I haven't even been using it that much, like on bug hunting. So it's a powerful tool. Your teams can use it. What do we want to do in the future? Well, we want more built-in methodologies to track. So we want to do PTES and the OAuth methodology, HIPAA, CREST, PCI, etc. We also want to port it to ZAP, because in order to use it, you need a pro version of Burp Suite. So we want to port it to ZAP so that anybody can use it without paying for the tool. The free version of Burp is, there is a free version of Burp, but this plugin, the APIs that it uses aren't available in the free version. So we want to port it to ZAP. We want to add more checks and vulnerability classes. We want to add more resources to help people manually test these vulnerabilities. We want a better GUI, because Perps GUI is hard to work with sometimes, and we're not the best with it. Then we want to add the ability to look for REST parameters. So instead of the parameter, the script resource equals parameter value, sometimes you pass data through URLs. So like /resource/parameter/value. So you don't use the equal signs or the question marks. We don't support REST right now. We just support the common vernacular for parameter value. We want to add more burp helpers, like things like highlighting to show you where the parameter is, and a whole bunch of other stuff. Cool. That's it, right on time. Thank you very much.